So in this video, we're going to discuss parallel lines and perpendicular lines. So as you see here, these are two parallel lines. The definition of parallel lines are lines that never intersect. Now, the reason they don't intersect is because they have the same slope. So notice if we were to look at both of these lines, the first one, notice it has a rise of 2 and a run of 1. So we rise 2 and we run 1. And notice that the y-intercept is 2. So you can actually already write the equation of this line, which would be y equals the slope, which is 2, times x, plus the y-intercept 2. The line in red, let's take a look at the slope. So if you could pick any 2 points, but notice you would have to rise 2 and run 1. And here, the y-intercept is negative 1. So the equation of this line would be 2x minus 1. So these are obviously two different lines, but notice what they share in common is the same slope. So because of this, they have the same steepness, and they'll never change direction to intersect with each other. Therefore, parallel lines will always have the same slope. So let's take a look at these 4 lines. We're being asked which of these lines are parallel to each other. Now, if you notice, 2 of these lines are actually very simple. The first one and the third one here are both in slope-intercept form. So when a linear equation is in slope-intercept form, it's very easy to identify the slope. So the slope for the first line is negative 3, and the slope for the third line is 2/5. So obviously, the first and third line are not parallel because they do not have the same slope. But now let's move on to take a look at the other 2 lines. Now these, if you recognize, are in standard form. The problem with standard form is that it doesn't tell you anything about the slope. So in order to figure this out, the best way to figure out the slope when a linear equation is in standard form is to rewrite it in slope-intercept form. So remember, all you have to do is rearrange the equation to solve for y. That way, then, it will become in slope-intercept form. So taking a look at the second equation, if our goal is to solve for y, first we'd remove the 4x. So we would subtract 4x to cancel that out. But of course, we have to balance out the equation and subtract 4x on the right side, leaving us with 10y equals minus 4x plus 1. Of course, you could say 1 minus 4x, but if we're trying to go into slope-intercept form, it's nicer if the x comes first. And now we need to remove this negative 10. So let's go ahead, and since we're multiplying by negative 10, we'll divide by negative 10 to cancel that out. And then we need to divide by negative 10. So remember, division must be distributed. So we'll get y equals, so negative 4 divided by negative 10. Well, a negative divided by a negative is positive, so we could actually ignore the negative. And then we have 1 divided by negative 10, which gives us negative 1 over 10. Now, at first glance, this looks tricky, but remember, fractions should always be simplified. So because 4 and 10 are both divisible by 2, we can then simplify this equation to give us 2 over 5x minus 1/10. So now you can see that the slope of this line is 2/5. Therefore, these 2 lines, the second and third line, are parallel to each other. Now let's see what happens with this last line. So if we write it in standard form, First, we'll subtract the 6x to cancel that term out. Again, I'm going to rearrange the order just to make this look a little nicer. So we'll say 2y equals negative 6x plus 5. And then we will divide by 2, both sides. That way this cancels out. And remember, we need to distribute that division. So we'll get y equals, so now we have negative 6 divided by 2, which is negative 3x. And then we have plus 5 divided by 2. So notice the slope of this line is negative 3. Therefore, the first and fourth line are parallel to each other because they have the same slope. So in order to determine if lines are parallel, you have to determine their slope. If it's already in slope-intercept form or even point-slope form, it's very easy to identify the slope. However, if it's in standard form, the best idea is to rewrite it in slope-intercept form so that you can easily identify the slope. So here are 4 different lines. So all of these lines are parallel except for one. So pause this video, determine the slope of each line, and figure out of these 4 lines which is the one that is not parallel to the others. Once you have figured it out, you may unpause this video and the answer will be revealed. So there you have it. If you have determined that A is the only line that's not parallel, then you got it correct. So notice the A is in standard form, so we rearranged it in slope-intercept form, and we found that the slope is 1. Remember that there's an invisible 1 right there. The second equation is already in slope-intercept form, so we already can immediately tell the slope. C is in point-slope form, and if you remember point-slope form, this is the slope, which is also easily identifiable, which is 2. And D, which is in standard form, if we rearrange it, we find that the slope is 2. Therefore, A is the only line that is not parallel to the others. Is the line that passes through the points negative 3, 4 and 3, negative 2 parallel to the line that passes through the points 4, 7 and 6, 5? Well, really, all you have to do here is figure out, do these lines have the same slope? So let's figure that out. So for the first line here, which passes through these 2 points, if you know 2 points, you can easily find the slope. So to recall, the formula for finding the slope is the change in y, so you find the difference of the 2 values of y, over the change in x, which is just the difference in the values of x. This is your rise over run. So for line number 1, the slope would be negative 2 minus 4 over 3 minus negative 3. But remember, when you subtract a negative, that becomes a plus. So we're going to get negative 6 over 6, which simplifies to negative 1. So if our second line has the same slope, then they will be parallel. So for our second line, since we know the 2 points that this line passes through, we can find the slope of the line. So we get the difference of the y values, 5 minus 7, and we get the difference of the x values, 6 minus 4. And this gives us negative 2 over 2, which simplifies to negative 1. Therefore, because the slopes are the same, yes, they are parallel. So the final type of question that you might encounter regarding parallel lines is, one like this, write the equation of the line that passes through the point 4, -7, and is parallel to the line y equals -5x plus 2. Well, in order to write the equation of a line, you need to know two things. You need to know a point, and you need to know a slope. Now, in this question, they're not directly giving us the slope, but they're basically telling us the information that we need to find the slope. So the fact that they're telling us that the line that we're trying to write the equation of is parallel to this line, well, if they're parallel, they're going to have the same slope. So if the slope of this line is -5, well, the line that we're trying to write the equation of is going to have the exact same slope, -5. So because we know a point and we know the slope, you can go straight to point slope form, which recall is like this, where m is the slope and x1, y1 is a known point. Therefore, as I always say, if you know a point and you know the slope, all you do is input them into point slope form. So y minus -7, which again becomes a plus, equals the slope, which is -5, times x minus 4. And here you have the equation in point slope form. If you want to write this equation in slope intercept form, depending on which form you're asked to give the line in, all you have to do is, of course, rewrite point slope form and slope intercept form. So the first step is to distribute the slope. And then we remove that 7 by subtracting it on both sides. You combine your like terms, and you get this equation. So both of these equations are the exact same line. They're just written in two different forms. I always recommend writing an equation in point slope form, and if you're asked to give the equation in slope intercept form, then you just solve for y. So let's try an example on your own. Line A has the equation y equals 1/2 times x plus 3. If line B is parallel to line A and passes through the point -8, 1, write the equation of line B in slope intercept form. Go ahead, give this a try on your own, and pause this video. Once you have solved it, you may unpause this video to find the answer. And there you have it. This is the equation of our line in slope intercept form. So because we knew the point that the line passes through, and we know that it's parallel to line A, and we have the equation of line A, which clearly tells us that the slope is 1/2, because the two lines are parallel, they have the same slope. Therefore, because we know a point and we know the slope, we were able to write the equation in point slope form. And then to write it in slope intercept form, you just have to solve for y. So let's take a look at perpendicular lines. Now, if lines have different slopes, they will eventually intersect with each other. However, perpendicular lines intersect in a very specific way. Perpendicular lines are lines that intersect at a right angle. So the best way to see the relationship between the slope of two perpendicular lines is to compare the equations of the two lines. So let's take a look at the line in red. Picking any 2 points on this line, we would see that we'd have to rise 2 and run 1. And we could also see that the y-intercept is -1. Therefore, the equation would be, well, the slope is 2 over 1, or just 2 times x minus the y-intercept 1. Now, the perpendicular line in blue, if we were to pick any 2 points, we'd see that we'd have to go down 1 and write 2. And we also see that the y-intercept is 4. So we can write the slope as -1 over 2 times x plus 4. Now, these two lines are perpendicular, and let's see what the slopes of these two lines tell us. Notice, for the first one, the slope is positive. For the second line, the slope is negative. If two lines are going to intersect at right angles, their signs are going to have to be opposite. Now, the other key thing here, which might not be obvious at first glance, is that the slopes are actually reciprocals of each other. So to do a quick review of the word reciprocal, if you have a fraction, the reciprocal of a fraction is just flipping the numerator and denominator. So if you have a fraction a over b, the reciprocal of that fraction would be b divided by a. Therefore, the slopes of perpendicular lines are, first of all, they have opposite signs. This means that if one of the slopes is positive, the other one is negative, or vice versa. And the second thing is that they are reciprocals of each other. So in order to determine if two lines are perpendicular, their slopes must have opposite signs, and they must also be reciprocals of each other. So let's take a look at these two examples. If a line has a slope of -2 divided by 3, what is the slope of a perpendicular line? Well, the slope of a perpendicular line must have two characteristics, as we saw before. First of all, the sign of the slope must be opposite. So because the sign of the slope given is negative, the slope of the perpendicular line is going to be positive. Now, you don't really show the positive, so you could just write this slope without the negative sign. And it must also be the reciprocal. So if the given slope is 2/3, the reciprocal of 2/3 is 3/2. And this is the answer. Positive 3 divided by 2. So because the slopes have opposite signs and they are reciprocals of each other, these are perpendicular slopes. Let's take a look at the second example. If a line has a slope of 5, what is the slope of a perpendicular line? Well, first of all, because our given slope is positive, the perpendicular slope will be negative. Now, 5 actually is a fraction. Technically, every whole number is a fraction. All you have to do is put it over 1. When you say 5, that's the same thing as saying 5 divided by 1. Therefore, the reciprocal of 5 divided by 1 would be 1 divided by 5. So this is the perpendicular slope. The sign is opposite, it's negative, and it is the reciprocal of 5, which is 1 over 5. So, are the lines y equals 3 divided by 4 times x plus 2 and 8x plus 6y equals 12 perpendicular to each other? So, based on the problems that we did when we were talking about parallel lines, you should be able to figure this out on your own. Just keep in mind, the first equation is already in slope-intercept form, but the second equation is in standard form, and the slope is not obviously given. So please pause this video and see if you can figure out if these two lines are perpendicular or not. Once you have found the answer, you may unpause the video to see the answer. So there you have it. By rewriting the second equation in slope-intercept form, we found that the slope was negative 4 divided by 3. The slope of the first line is 3/4. So because the signs are opposite and the slopes are reciprocal to each other, therefore, yes, these two lines are perpendicular to each other. So write the equation of the line that passes through the point 6, 2 and is perpendicular to the line y equals negative 3 times x plus 5. Now, remember, to write the equation of a line, you must know a point and you must know the slope. So we do know the slope of this line, and that is negative 3. But the key here is that the equation that we're trying to write is perpendicular to the given line. So if the slopes are perpendicular, that means their sign must be opposite and they must be reciprocal to each other. So the slope of the perpendicular line would be positive 1 divided by 3. So remember, negative 3 is the same thing as saying negative 3 over 1. So the reciprocal of 3 over 1 is 1 over 3. And of course, the signs are opposite. So because we know the slope and we know the point, we can write the equation in point-slope form. And this is the equation. And of course, if you want to write the equation in slope-intercept form, you then distribute and solve for y. So this is the equation in slope-intercept form. So give this problem a try on your own. So line A is y equals 1/2 x minus 5. Line B, we know, will be perpendicular to line A, and it passes through the point negative 1, negative 3. Write the equation of line B in point-slope form. Pause this video, give this a try, and once you have found the answer, you may unpause the video to see the answer. And there you have it. We already know the point that line B will cross through, and even though I'm not telling you directly the slope, the fact that we know that it's perpendicular to line A means we can find the slope. So if line A has a slope of 1/2, line B will have the perpendicular slope of negative 2. Or you could say negative 2 divided by 1, but remember, you don't really need to show that division by 1. Therefore, because we know the point and we know the slope, we can write the equation in point-slope form. So the last note I want to make before we wrap up this video is let's take a look at two very strange linear equations, which are horizontal and vertical lines. These pretty much are the only weird exceptions to the other linear equations that we've seen before. So recall that a horizontal line has the equation y equals some number. This means that regardless of the value of x, y is always going to be whatever number it's equal to. So it creates a horizontal line at that value of y. So for example, if you wanted to graph the equation y equals 3, that means you just do a horizontal line at y equals 3. And recall that vertical line has the equation x equal b. So regardless of y, x is always going to be whatever number it's equal to. So for example, if you wanted to graph the equation x equal to -2, you draw a vertical line at x equal to -2. Because no matter what point you pick on that line, x will always be -2. Now, the slope of a horizontal line is very interesting because notice there's no rise. So let's say, for example, we wanted to find the slope between these 2 points. So notice that the rise is 0, but the run is 1. Therefore, the slope is 0. All horizontal lines will always have a slope of 0 because there is no rise. So if there's no rise, you will have a slope of 0. Now, vertical lines are very strange because notice that there's now no run. So let's take, for example, that we wanted to find the slope between these 2 points on this vertical line. So notice that the rise is 1, but the run is 0. Now, dividing by 0 is actually a mathematical contradiction. Dividing by 0 will always give you an undefined answer. So this is very strange, but a vertical line will always have an undefined slope. The relationship between a horizontal and vertical line is that they're actually perpendicular to each other. But because, the slopes are not positive or negative, remember, 0 is neither a positive or negative number, and of course, an undefined slope doesn't actually have a number. This is the only exception where the rule of perpendicular slopes does not apply. But if you have a line that's horizontal with a slope of 0, its perpendicular line will be a vertical line, which will have an undefined slope. So that's it for this video. I hope that you found this useful, and I'll see you in the next video. Bye.